Hi, and welcome to this next video on OCR A-Level Biology, OCR A-Level Chemistry. We're still on Module 2.1, which is Atoms and Reactions, and in this short video we're going to be looking at ions and the periodic table. So, ions, as we saw in the last video, have some charge. So as we saw here in the last video, we were looking at what the differences between a sodium atom and a sodium plus ion. And this is true for all ions, but different elements have different numbers of electrons lost or removed, and that can lead to different charges on the ions. So you can predict the ionic charge based on the group that the element is in. So for instance, so let me just introduce ourselves to this. So we're looking at ions. Hold on, let me adjust my set so you can hear me better. Okay, so we're looking at ions. So different, as I said, different groups within the periodic table have different numbers of ions. So for instance, in group 1, the number of outer shell electrons in the ion is, we have 1 plus ions. And the examples, which are right in this green color, are Li plus, Na plus is a common one. What else do we have? K plus as well. Cs, so cesium plus as well. So these are all group 1 ions. They all lose 1 electron. So they have minus, so the number of electrons equals number of protons minus 1. So whoops, that's the key thing here. So if I do this in a different color, so the number of electrons is equal to the number of protons minus 1. So that's true for all group 1 ions. Group 2 have 2 plus ions. For instance, we have Mg2 plus, so magnesium 2 plus ions, and also I think calcium, yes, calcium 2 plus ions. So for these ones are Ne. So we have Ne is equal to the number of protons minus 1. No, not minus 1, minus 2. So magnesium 2 plus, Ca2 plus, these are all group 2 ions. Now we're going to look at group 3. So group 3 form 3 plus ions. And the classic example here is aluminium. So aluminium is a group 3 ion. And in this case, we have the number of electrons is equal to the number of protons minus 3. So you can see a pattern here. So you would expect group 4 to have 4 plus ions. and group 5 to have 5 plus ions, so that's what the pattern you would expect. But in fact, group 4 does not form ions. So carbon and silicon, these all form covalent compounds, not ionic compounds, as we'll see in the future video. So this group, group 4, produces no ions because they are all in covalent bonding. So they're all involved in covalent bonding. Now it will look at group 5. So it gets different here when we move into group 5. So group 4 is basically the threshold. So no, group 3 is basically the threshold for the positive ions, for the cations. But we also have anions. And group 5 is the start of the 3 minus ions. So instead of having taken away electrons, we are now adding electrons. One example is the N3 minus ion, but also the P3 minus ion as well. And in this one, we have number of electrons is equal to the number of protons plus 3. So we have 3 extra electrons. Group 6, well, they're calling it group 16, but that's just the way their periodic table is structured. But in a proper periodic table, you have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8, or group 0. So group 6, these are the 2 minus ions. So for instance, we have the O2 minus ion, and whoops, that's a different color. So for instance, we have the O2 minus and the the sulfur. Yes, the sulfur 2 minus ion. And the general equation for number of electrons is always equal to the number of protons plus 2. So you would expect, like in the correct way, that group 7 would have 1 minus ions. And that is correct. Group 7 have 1 minus ions. Examples being Cl minus, F minus, Br minus, I minus ion. All of these are the group 7 anions. And their general formula for number of electrons is always equal to the number of protons plus 1. Now group 0 or group 18, group 0 does not take part in, group 0 elements because they have a full shell of outer electrons. They do not take part in any chemical reaction. So we're going to skip and leave out group 0. But you can see here that group 1, group 2, group 3 these are all the cations. And you can see that they're all generally metal, usually metal. The groups 5, 6, 7, which you can see here, these are all anions. And these are usually non-metal. So using this sort of like sketch or diagram that I've used, we can start to predict the chemical formula or the ionic formula for certain compounds when some of these elements mix together. So for instance, and remember, an ionic compound, no matter what the charges are, always has a neutral charge overall. An ionic compound must maintain stability. In order for it to maintain stability, it needs to have a neutral charge. So here we're just going to do some basics here. So cations, so we're going to draw a little table here. Discussing cations and anions. So here cations, whoops, I did not mean to do that. And anions. So cations, these ones are usually metal and they lose electrons. They lose electrons and form positive ions. And they have electron configuration of the previous noble gas. If you don't know what I mean by noble gas, basically group 0 is the cyanote. Noble gases, just a little side note. These are helium, argon, what else is there? Neon. Basically, these are group 0 or group 18, as they're called in the textbook. The anions, these ones gain electrons and they form negative ions, and they have electron configuration of next noble gas. So for instance, if we look at, say, lithium, lithium is a positive ion. So lithium, if we look at the picture of the table, lithium is a positive ion. So it's in period 2. So hydrogen and helium, hydrogen specifically, actually hydrogen should be in here because hydrogen's technically in group 1. So I'm going to put hydrogen in brackets. So H plus does form like positive, but then for this one it's just a proton. But technically it should be in group 1 because it does form 1 plus ions. So lithium, the noble gas before lithium is helium. So lithium loses its single electron to maintain stability and maintain and have the electron configuration of helium. Whereas oxygen gains 2 electrons in order to have the electron configuration of neon. To have the electron configuration of neon. Okay, so now we're going to look at group. So this is interesting. So some of these elements, particularly in group 4, as I said, do not form ions usually. And this also applies to some elements in groups 2 and 3. So for instance, beryllium, which is in group 2, boron, which is in group 3, and carbon and silicon, which are both in group 4, they do not normally form ions because they require too much energy, and this is important, they require too much energy to transfer the outer cell electrons to form ions. So that's why beryllium, boron, carbon, and silicon don't normally form ions, because it requires too much energy to transfer the outer cell electrons. So beryllium, boron, carbon, silicon, they don't form ions. But all the others in groups 1 to 3 and groups 5 to 7, I don't know about the rest of group 4, but definitely carbon and silicon can't form ions. Can form ions. So, also, a little side note about the transition metals. So the transition metals are located between groups 2 and groups 3, or in this case, groups 2 to groups 13. So, in the textbook version of the periodic table, then it's actually groups 3 through 12 are the transition metals. But in the actual version, the actual periodic table, is just that bigger gap between group 2 and group 3, which are the transition metals. And these elements can form more than one ion, each with a different charge. So for example, iron can form Fe2 plus and Fe3 plus. Copper can form Cu plus with a plus 1 charge, and Cu2 plus with a plus 2 charge. And these can have different colors depending on the charge of the ion, which you will learn about in year 2 when you talk about the transition metals specifically. So yeah, the transition metals have their own topic, and that comes in year 2 because they're much more complicated. Anyway, molecular ions. So there are some small groups of covalently bonded atoms that can also lose or gain electrons to form ions, and these ones are called molecular ions. So hopefully you can still hear me. Yes, you can. Okay, good. So we're now going to look at molecular ions. So molecular ions are groups of covalently bonded atoms which can lose or gain electrons. So we have some examples of molecular ions, and sadly, unfortunately, you have to just memorize these. So some of these, but they are common. You have to just memorize the common ones. So the common ones are, and you have to memorize these because there's no other way of getting around it. So it's the NH4 plus. So that's a positive cation. The ammonium, so this is known as the ammonium ion. I'll write that in a different color. Ammonium. We have OH minus, which is the hydroxide. We have nitrate, which I will write up here. And we also have carbonate and sulfate. So the nitrate ion is NO3 minus. Carbonate is CO32 minus. And the sulfate is SO42 minus. So these are the molecular ions that you need to be able to do. that you need to be able to understand and just learn from memory. You just need to do these. So now we're going to look at how we can predict ionic formula given the charges, given that we know the charges of some common ions. So prediction of ionic formulae. Prediction of ionic formulae. I was going to write prediction ionic formulae, but this sounds a bit better. Okay. Or maybe it doesn't. Who cares? Anyway, prediction ionic formula. You must remember that in an ionic compound, the overall charge must be zero. So although an ionic compound is made up of oppositely charged ions, its overall charge, its net charge must be zero. So here in an ionic compound, so positive charge. So how do I write this? So let's do number of positive plus must equal number of negative. That doesn't make any sense. But what I'm trying to say here is the total number of positive charges from positive ions must equal the total number of negative charges from negative ions, from anions. So you can write an ionic formula by following some simple rules. So in an ionic compound, and I will actually write this because this is important. In an ionic compound, the overall charge is equal to 0. So that is a key point. In an ionic compound, the overall charge is equal to 0. And no, I do not want to do that. So let's have a go for an example. I should have put this in my chem calculus series, but you guys, I've already done it. Never mind. So let's go with example 1. So I'm going to give you an example to do. So first thing is you want to do calcium. Let's do the one that they gave in the book. Calcium chloride. So if we want to do calcium chloride, you can already predict, we know from our little table, and that table is, there's a better table in page 40 of the textbook. So we know here from our table, not this table, calcium chloride. So we have Ca and Cl. So if we look at calcium, we can see that calcium is a 2 plus ion, and Cl, I should have shown you, and Cl is a 1 minus ion. So we have Ca. So first we write down what are the ions that we know. So we have Ca2 plus Cl minus. But remember, here we need the overall charge to be equal to 0. So since Ca has a 2 plus ion, but Cl has only a 1 minus ion, and we want to make the overall charge equal to 0, we must have another Cl minus ion. Okay, Ca2 plus 2 Cl minus So because here Ca has 2 plus, and we need each 1 minus to cancel out that 2 plus. So that gives us Ca2 plus 2 Cl minus. Okay, so we don't write it like this, we write it like CaCl with a little 2, and that 2 corresponds to this 2, and this 2 corresponds to each of these minus. So that's our final answer. The formula for calcium chloride is CaCl2. Here's another one, which you can pause. Here's another one, which I'll give you to do. So this one will be, let's do one that they've given. Here's an interesting one. Let's do lithium nitride. Let's do lithium. So this is one going in the textbook. Lithium nitride. Okay. Go ahead, have a look, pause the video, see if you can work out this formula. Okay. So hopefully we've worked out that lithium from our table is a Li plus. Actually, I'll do that in a different color. Whoops. Hopefully you've worked out that lithium has a positive, a 1 plus ion, and nitrogen has a 3 minus ion, because it's in group 5, they produce 3 minus ions. Now, in order to balance out this 3 minus ion, we're going to need more than one lithium ion, because here we have a 3 minus ion, here only a 1 plus ion. So that indicates that we need 3 Li plus to go along with the N3 minus ion. And we don't write it like this, we write it as Li3N. And there's your final answer. I'm going to give you one more, and this one's interesting because it's a transition metal, but they've given you the ion to use, so it's fine. So this is the final example that I'm going to give you. And this is let's do iron chloride, but not any iron chloride. This is iron chloride. Pause the video, see if you can work out yourself, because this one, I've given you a little bit of help here anyway. So pause the video, have a look, see what you come up with. Okay then, so you should have worked out that the iron 3, this bit means that we're working with the Fe3 plus ion. And obviously this bit, we already know, is that we're working with the Cl minus ion. So iron chloride, we have Fe3 plus, to balance out this 3 plus on the iron, on the iron, that sounds very hard to say, on this iron, we need 3 Cl minus. So we're going to have 3 Cl minus ions, and that will give us FeCl3. And there's your final answer. Okay, so this prediction of ionic formula is a little bit tricky, especially, but once you practice, especially with these transition metals, then it'll become much easier. You'll almost feel like, you almost feel like it'll be in your brain and it'll be easy to do. Anyway, that is going to be it for this episode here, for this video here. Thank you all very much for watching. In the next video, we're going to be looking at amount of substance and the moles. Thank you very much for watching, and I'll see you all later. Goodbye.